Hello, welcome back. In this video, we're going to go over an exercise where we're going to try to find the average and instantaneous velocities for a moving object. And for this purpose, we have a rocket problem. A rocket is shot upward from the surface of the Earth with an initial velocity of 120 meters per second. And the question is asking, what is its velocity after 5 seconds, 10 seconds, and once we come up with those, these are going to be the instantaneous velocities for this object at the time moment 5 seconds and 10 seconds. And then we're going to find the average velocity between t equals 5 and t equals 10 seconds. And here the position function is provided to us. And this, in fact, this is the position function for a free-falling object. So it's a quadratic, and the position function has the initial velocity and initial displacement part of the quadratic, v0 and s0. Well, the initial velocity is provided to us as 120 meters per second, so we're going to go ahead and replace this v0 by 120. And since the rocket is shot upward from the surface of the Earth, so the initial displacement of the rocket is going to be 0. So S sub 0 is essentially just 0. So what we're going to do in the next step is we're going to find the instantaneous velocities. And to achieve that, we need S prime. S prime is the rate of change of the position function in time. That's the velocity of the rocket. So as we mentioned earlier, v sub 0 is 120 and s sub 0 is 0. And we're going to go ahead and take the derivative of this function by using the power rule. So for this one, it's going to be 2 times minus 4.9. So, or let's just keep this, minus 4.9 times 2 times t to the power of 1, which is just t. And for this one, while this is constant multiple of t, the derivative of that is just going to be 120. So this is minus 0.9 t plus 120. We are asked to calculate the instantaneous velocities at time t equals 5 and time t equals 10. So all we're going to do is evaluate s prime at 5. S prime comes with this expression here. And also s prime at 10. All right, you can use your TI-84 to plug in 5 for t here for this case, and then 10 for t. And we get the instantaneous velocity at time t equals 5 to be 83 meters per second, and at time t equals 10, that's 22 meters per second. And I also write down the location of the rocket at time t equals 5 and time t equals 10. As you see, from t equals 5 to t equals 10, there is a decrease of the instantaneous velocities, even though the altitude here increases from 477 to 710. So that means that the rocket is slowing down as the time evolves. And this graphical outlook shows the location of the rocket in 5 seconds and in 10 seconds. As you see, if you look at the tangent lines here, at this point and at that point, here the tangent line has a steeper slope than the tangent line here. So that means that the rocket is slowing down, and at some point it's going to make a peak, and then it's going to start falling down all the way. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.